the top of page 2, you're given find an equation of the circle with center at -3, 2 that passes through the point 1, 4. Find the x and y intercepts. Okay. So the equation of the circle in standard form, right, is x minus h squared plus y minus k squared is equal to r squared, right? The x coordinate, right, for the center of the circle is at h, and the y coordinate is k, and r is the radius of the circle. Okay. So in this case, the center is at -3, 2, okay? And so h is equal to -3, k is equal to 2. Okay? And so substituting in for h and k in standard form for the equation of the circle, you have x minus a -3 quantity squared plus y minus 2 quantity squared is equal to r squared. You know, minus a minus, the same as plus a positive. So we have x plus 3 squared plus y minus 2 squared is equal to r squared. Now, the graph of this circle passes through the point 1, 4. Right? 1 is the x coordinate, 4 is the y coordinate. So x and y, right? X equals 1, y equals 4 has to satisfy this equation. So we put in 1 for x, 4 for y, and then solve for r squared. Get the radius squared for this circle. So we have 1 plus 3 squared plus 4 minus 2 squared is equal to r squared. And now it's just PEMDAS on the left-hand side, right? See what's in parentheses, then exponentiation, then the addition. Right? So 1 plus 3 is 4. 4 squared is 16. 4 minus 2 is 2, and 2 squared is 4. So we end up with r squared is equal to 20. So we replace r squared on the right-hand side over here, and now we have the equation for this circle, right? That has this center and passes through this point. So we have x plus 3 squared plus y minus 2 squared is equal to 20. Now 20 is not the radius, right? 20 is the radius squared. So if you know what the radius is, you got to take the square root of both sides, right? And you get r is equal to square root of 20. And when you reduce that, you get 2 root 5. Right? So r squared is the radius squared. All right. So we found the equation of the circle with center -3, 2, and then passes through the point 1, 4. Right. So we've done the first part. Now we got to find the x and y intercepts. Well, to find the x-intercepts in the graph of an equation, right, you set y equals 0 and solve for x. Remember, the x-intercepts where the graph either crosses or touches the x-axis. And where it crosses or touches the x-axis, the y coordinate is 0. So we just set y equals 0 and solve for x. So here's our equation. So we have x plus 3 squared plus 0 minus 2 squared is equal to 1. Now we solve for x, right? Put 0 in for y. Now solve for x. So we have x plus 3 squared plus 0 minus 2 in parentheses negative 2, and negative 2 squared is 4. And now we subtract 4 from both sides. We get x plus 3 squared is equal to 16. Now you could FOIL this and write it as a quadratic equation of one variable and then factor, use quadratic formula, but we can actually use what's called the square root method to solve for that, for x. Right, what I'm just squaring? Square root, right? So we take square root of both sides. And when you solve an equation using the square root method, what am I missing on the right-hand side? Plus or minus, right? There are two solutions. So on the left side, we have x plus 3 is equal to plus or minus square root of 16 is 4. So x plus 3, right? So first you use the plus sign, right, on the right-hand side, then you use the minus sign. So we have x plus 3 is equal to 4, or x plus 3 is equal to negative. So on the first equation, you subtract 3 from both sides, and you get x is equal to 1. And when you subtract some 3 on both sides over here, you get x is equal to minus 7. So the graph of this circle, right, in this case crosses the x-axis at x equals 1 and at x equals minus 7. And you can write those x-intercepts as ordered pairs. First one's 1, 0. The second one is minus 7, 0. You can write it either way. I don't know what WebAssign wants. They might just want the what x is equal to, or they might want the ordered pair. I can't remember. But you one or the other. Okay. All right. So the y-intercepts, where the circle crosses or touches the y-axis, okay, we set x equal to 0 and solve for y. So we go back to our equation in standard form and put 0 for x and then solve for y. Same technique. So when we put 0 on for x, we have 0 plus 3 squared plus y minus 2 squared is equal to plus 20. Well, 0 plus 3 is 3, and 3 squared is 9. So we have 9 plus y minus 2 squared is equal to 20. And now we subtract 9 from both sides. We have y minus 2 squared is equal to 11. Now we take the square root of both sides. We get square root 11 plus or minus the square root 11 on the right-hand side. So now we have y minus 2 is equal to plus or minus square root 11. Let me erase this. So using the plus sign first, right? The y minus 2 is equal to plus square root 11. And using the minus sign, we have y minus 2 is equal to minus square root 11. Adding 2 to both sides, get y is equal to 2 plus the square root 11, or y is equal to 2 minus the square root 11. You can't reduce that. 2 is a rational number, square root 11 is an irrational number. So, you can write these as an ordered pair if you want, right? It depends upon what Webb assigned, right? You may have to write it as the ordered pair of 2 plus the square root 11, comma 0. Did I do that right?
No, it would be
It's backwards. X 0. That's how you may have to enter Webb assigned, right? It's an ordered pair. The x coordinate is 0, the y coordinate is either 2 plus root 11 or 2 minus root 11. Okay. So those are the y-intercepts. Okay. So let's draw a crude graph of our circle, right? Because you're going to be doing graphing this semester. Okay. So you might as well start now. Okay. So as I've told you, I think I told you already, when I graph a circle in the coordinate plane, I got to draw the circle first and then add the x and y axis, right? The circle looks really bad. Okay. So we know the location of the center of this circle is at minus 3, 2. And the radius is square root of 20, which is about 4.4. Okay. So the distance from the center, this is x, right, x equals minus 3, so the distance from the center to the edge of the circle is 3 units. Okay. No, I said that wrong. The distance from the center to the edge of the circle is around 4.4 units. Okay. And the center is only 3 units to the left of the y-axis, right? So the y-axis has to cut through the circle, something like that. Right? So the distance from the center to the y-axis is 3 units, but the distance from the center to the edge of the circle is 4.4. Now the distance of the center to the x-axis is only 2 units, right? Because you go and you draw it. Now this isn't drawn to scale, right? But the distance from the center, right? So here's minus 3 on the x-axis, and here's plus 2 on the y-axis, right? So the distance from the center to the x-axis is only 2 units, okay? Because to plot this point, right, the origin to the left, 3 units, and then up 2, right? So the distance from the center to the x-axis is only 2 units, but the distance from the center to the circle, point on the circle vertical, is 4.4. So the x-axis cuts through it, something like that. Okay. Here's the origin. So this point right here, where the circle crosses the x-axis, is minus 7, 0, right? one of the x coordinates over there. And this x coordinate right here where it crosses the circle is the 0.10, right? So those are the two x intercepts. Okay. Now 2 plus square root 11, right, is bigger than 2 minus square root 11. Right? So this point right here, okay, is the y-intercept 0, 2 plus square root of 11, where it crosses the y-axis up there. And down here, square root of 11 is actually greater than 2, right? It's more than 3, but less than 4. And so 2 minus square root of 11 is a negative number. And that's why this y-axis is below the origin. So this is the point 0, 2 minus the square root. And so that's the graph of this circle right here, right? The crude graph of this circle right here with the 4x intercepts there. Any questions on that, ladies and gentlemen? Yeah, you'll be doing a lot of graphing this semester. Yeah. So it's a good skill. And then those of you who have to take Calc 1, right, you'll be doing a lot of graphing in that by hand, right? All right. So let's take a look at the next problem, the bottom of page 2. It says, find an equation of circles centered at -4, -1 that is tangent to the vertical line, x equals -1. Now, the word tangent means to touch. Okay. The circle just touches, the edge of the circle just touches that vertical. Okay. And since the line is x equals -1, that's how we write the equation of a vertical line. Okay. All right. So the center is at the point -4, -1. Right. So h is equal to -4 in this case, and k is equal to -1. Okay. So we're going to find the equation in the circle centered at -4, -1 that's tangent to the vertical line x equals -1. Okay. And then sketch the graph of the circle. So I have provided you with a coordinate plane. And again, I'm going to draw the circle for it first. And the center is at -4, -1 in the coordinate plane. Okay. And this circle is tangent to the vertical line x equals -1. So that means the far right edge of the circle just touches the vertical line x equals -1. Okay. So you can, I provided you with a grid. Okay. So the vertical line that crosses the x-axis at -1. The right edge of the far right edge of the circle and that vertical line just touch at that one point. Okay. The vertical line doesn't intersect the circle; it just touches it, right? And then 1 unit over is the y-axis. Here's the y-axis. So this is like the point, here's x equals minus 1. So this has to be the point minus 1, minus 1. Okay. So to get to this point, right, you got to go 4 units to the left of the origin and then down 1 unit, right? So that means the x-axis is directly above. Now, I provided you with a grid, ladies and gentlemen, right? So you can just go on your grid, you can go to minus 4 on the x-axis and then down 1. Okay? What I have a problem with now is drawing a good circle, okay? After the grid is drawn. And that's why I draw the circle first. I can draw a decent circle by freehand, but I have a hard time drawing a good circle freehand inside a coordinate plane. Okay. So I provide you the coordinate plane. You just go to the point minus 4, minus 1. That's where the center is. And then you're going to draw a circle that just touches the vertical line, x equals minus 1. Right? Here's minus 1 on the x-axis. Right? But I'm sort of doing it backwards. Okay? I draw the circle first, and now I'm filling in the x and y axis. So here's minus 4 on the x-axis. Here's minus 1 on the y-axis. Here's our location of our center. Okay. Well, that's the point 0, minus 1. This is the point right here where it just touches the circle. Right? This is minus 1 on the x-axis. And so this is the point minus 1, minus 1. And using either the distance formula between those 2 points, right? Calculate distance from the center to the edge of the circle. Either using the distance formula or by inspection, right? Since we're going horizontally directly to the right, you can see that it's only 1, 2, 3 units from the center to the edge of the circle. So you can conclude the radius r is equal to 3. By inspection or using the distance formula. Okay. You can use the distance formula to calculate the distance from the center to the edge of the circle, by using the points minus 4, minus 1, and minus 1, minus 1. You can see the y coordinate is the same for these 2 points. So all you got to do is take the difference in the x coordinates to get the radius. Okay. So you can do it by inspection, right, or using the distance formula. And now that we know h, k, and r, we can write out the equation of the circle for this situation. Okay. So we have x minus h squared plus y minus k squared is equal to r squared. X minus h is x minus a negative 4 quantity squared. And we have y minus a negative 1 quantity squared is equal to 3 squared. R is equal to 3. So minus a negative 4, same as plus 4. And minus a negative 1 is the same as plus a positive 1. 3 squared is 9. So the equation of the circle that has a center at -4, -1, and is tangent to the vertical line, x equals -1, has that equation. And it's because of the tangency we know the radius is 3. And again, you can get it by inspection, just by looking at the distance between those 2 points, or using the distance point. Any questions on that one, ladies and gentlemen? All right. So now we're going to take an equation of a circle in general form and rewrite it in standard form. And to do that, we have to use a technique called completing the square. Okay. Okay. So if I have the trinomial x squared, and I'm making this up off the top of my head, okay? X squared plus 6x plus 9. Okay. That factors into x plus 3 times x plus 3, which is equal to, can be written as x plus 3 squared. So this is called a perfect trinomial. And this is called a perfect square. So whenever you can take a trinomial, okay, quadratic, okay, variable x, and write it as a product of a factor times itself, that creates what's called a perfect square. Okay. And we have perfect squares, you use perfect squares in reducing radicals, right? 2 squared is equal to 4. 3 squared is equal to 9. 4 squared is equal to 6, 16, and so forth, right? You use perfect squares to reduce radicals all the time. You probably don't think of it that way. And so we're going to use perfect trinomials that can be written as perfect squares to rewrite an equation of a circle in general form, go from general form to standard form. Okay. That's what we're going to do. We're going to use perfect trinomials that can be written as perfect squares. Okay. All right. So let's take a look at the first example. Okay. The best way to learn this stuff is just do it. So on A, we have x squared minus 2x plus y squared plus 4y is equal to 4. Now, step number 1. So this is called general form. And now we got to rewrite it in standard form, right? This is standard form up here. It's algebra. Okay? And so how we're going to go from general form to standard form is we're going to create 2 perfect squares, or perfect trinomials on the left-hand side. One into variable x, one into variable y. Okay? You must sweaty hands. And then rewrite those perfect trinomials as perfect squares to get the equation of this circle in standard form. Okay. All right, so first thing you got to do is make sure the x terms, right, are together. The y terms are together. And any constants get moved over to the right-hand side. Now, we're going to add two numbers to both sides of the equation in order to create a perfect trinomial on variable x and a perfect trinomial on variable y. So we have x squared minus 2x, and I'm going to put a blank where we're going to add a number to the left-hand side to the two sides to create a perfect trinomial in variable x. And then we do the same thing for the variable y. And you know, whatever you add to the left-hand side, you got to add to the right-hand side, right? Where you change the equation. So we have 4 plus blank plus blank. Okay. Now, this is explained in general terms in the rectangle up here. But to find the number that we had to add to both sides to create a perfect trinomial in the variable x, you take the number in front of the x, in this case minus 2, you divide that number by 2, and then you square the result. Okay. So divide by 2, square the result. Well, minus 2 divided by 2 is negative 1, and negative 1 squared is plus 1. So we're going to add 1 to both sides, okay? So we have x squared minus 2x plus 1, right? Goes in the first blank. Left-hand side. And 1 goes in the second blank. Right, the first blank on the right-hand side. Right? So we add 1 to the left and 1 to the right. Now to create a perfect trinomial on the variable y, we take the number in front of the variable y here, which is 4. We divide it by 2, and then square the result, just like we did over here. Well, 4 divided by 2 is 2, and 2 squared is 4. So now we're going to add 4 here and over here to create the perfect trinomial in the variable y. This perfect trinomial can be factored as a perfect square, and this trinomial can be factored as a perfect square. And when we do that, we'll have the equation in standard form on the left-hand side. Well, x squared minus 2x plus 1 factors into x minus 1 times x minus 1. Right? I'm adding a little additional detail, right? With time, you just know this is x minus 1 squared. Okay. And y squared plus 4y plus 4 factors into y plus 2 times y plus 2. And the right-hand side, 4 plus 1 plus 4 is 9. And x minus 1 times x minus 1 is x minus 1 squared. Y plus 2 times y plus 2 is y plus 2 squared. Okay. And r squared is equal to 9. So that's the equation of the circle in standard form. Now you'll notice that the numbers that go here to here in our perfect squares, here it's -1. That equals -1 in parentheses over here. And the +2 equals +2 in parentheses over here. So if you have trouble factoring the numbers, right, when you divide this number by 2, it tells you what number goes here with the variable x. When you divide this number by 2, it tells you what number goes here with the variable y. Okay. So now do we know where the center is located and what the radius of the circle is? Certainly, right? From up here. What's h equal to in this case? Is that true? You got to change the sign, remember? Yeah, so it's h is +1. K is what? And r is what? Right? You take this, r squared is equal to 9. So when you take square root of it, the radius can never be negative, right? The radius can never be negative, so you get the positive square root of those things. So the center is located at the point h comma k, which is 1 minus 2 in this case. And the radius r is equal to 3 in this case. Any questions on that, ladies and gentlemen? So you take the equation of circle in general form, create 2 perfect trinomials, one in the variable x, one in the variable y. Okay? And then when you factor those perfect trinomials as perfect squares, you have the equation of the circle in standard form. Okay? That's the process. Any questions on that? So I'm going to release this homework 1.4 today, and it'll be due Thursday.